Hi everyone, Caoimhin here from CIT's Blackrock Castle Observatory. In this video, we aren't going to look at tonight or today, but forward to the 21st to the summer solstice, and we're going to look at how the sun moves across our sky over the year. If you're interested in the motion of the sun over the year, then make sure to stick around till the end of the video, and if you're interested in the sun, stars and planets in general, make sure to subscribe to our YouTube channel by hitting the red subscribe button next to this video, and if you'd like to get all of the most up-to-date notifications, then make sure you hit the little blue bell icon next to the subscribe button as well. So we're here very much in the middle of the day. It's 1:30, and of course in the middle of the day the sun reaches its highest point in the sky. On the summer solstice it reaches its highest point all year long. So we can certainly see that the sun is quite high here, and if we start moving forward to December, we'll see that the sun does get lower and lower, noticeably lower almost each month until it reaches its lowest here in December. There are a few ways to measure how much the sun's position in the sky has changed. One of the best ways is by using a shadow, the shadow of a stick or a tree or yourself. Your shadow should be much shorter on the longest day of the year because the sun will be higher. On the shortest day of the year, your shadow will be much longer. In some parts of the world, the sun directly passes overhead, and this means your shadow is pretty much invisible at midday. Of course, in other parts of the world, during the middle of winter, the sun doesn't rise at all, so you just don't get a shadow. Here in Ireland, our grid shows us that on the longest day of the year, the sun is about 60 degrees up in the sky. If it was in the very middle of the sky, it would be up at 90 degrees. If we start moving forwards to December again, we will see the sun is getting lower and lower, but now we can see exactly how low it gets in degrees. So here we are on the 21st, and we can see over here it's 10 degrees and 20 degrees, so the sun is a little closer to 10 degrees in the sky than 20. If we were right up at the North Pole for the winter solstice, the sun would actually be below the horizon, less than 0 degrees, so it would be invisible. Of course, the winter solstice up at the North Pole is the summer solstice down at the South Pole. So different sides of the planet get their solstices at very different times of the year. And the same is true for the spring, summer, winter, all of the seasons. We get our summer while the South gets its winter. Our tilt towards the sun is what causes the difference between our high sun in the summer and our low sun in the winter. When we're tilted towards the sun for summertime, we'll see it much higher in the sky, but this also causes it to stay in the sky for longer. So if we want to see the path that the sun takes across our sky, we use the ecliptic. It's the same line we use for measuring the path of the moon and the planets. So here is our ecliptic. You'll see that it goes right behind the sun. It comes up in the east here where the sun rises and goes down over in the west. But if you were looking at sunset or sunrise on the summer solstice or the winter solstice, you won't see the sun directly in the east or in the west. If we move back towards morning time, you'll see that this line of the ecliptic appears to drift, pushing back towards the northeast, and we will see the sun rising in the northeast during the summer. If we're looking at the sunset, it's very similar. It won't be in the west, but in the northwest, as we can see here. During the middle of winter, the exact opposite happens. So if we bring our sun back up to the middle of the sky, we can see the ecliptic is going from west to the east. If we start moving through the year, that will change. We'll see the ecliptic seem to wobble, and this is as we pass the equinoxes, coming back up to east and west once we reach the shortest day of the year. So there's the ecliptic a little bit to the east and the other side of the ecliptic over to the west. But the sun will rise and set southeast and southwest, as we can see here. As we push back to morning time on the shortest day of the year, well, there is the sun just rising at almost 9 o'clock in the southeast. If we push forward to evening time, we'll see something very similar. The sun will be setting in the southwest as early as just 4 or 5. So the sun's path across our sky changes. Not just how high it is in the sky, but where it rises and sets. And that has an effect on how long our day is. If we come back to September, and we'll come back to September 22nd, that is when our equinox will be this year. This will be the autumn equinox. For us, September is in the autumn, but if you're on the other side of the planet, if you're down south, then it will be a little different. Your equinox will still be on the 22nd, but it will be your spring equinox instead. And there we are on the equinox. The sun is actually rising directly in the east, and if we push all the way over towards nighttime, we'll see that it goes down almost exactly in the west. There is a little bit of a tree, but trust me, the sun is right behind the west there. Something very similar happens for our spring equinox in March, the autumnal equinox on the other side of the hemisphere. So if we come all the way back to the 3rd month of the year, here we go. We'll see the sun isn't particularly high in the sky. We're looking at the 20th of March. The sun will rise in the east and set in the west. So you really only have one time in the year where the sun is at its highest and one time in the year where the sun is at its lowest, but we do get 2 times each year to see the sun exactly in the middle of the sky and rising exactly in the east and in the west. So the solstices and the equinoxes, we get them and we have these different lengths of the day and different heights of the sun because of the way the earth is tilted. I did mention that if you are at the very, very top in the North Pole or the very, very bottom down in the South Pole, during summer the sun won't set at all, and during winter the sun just doesn't rise. We aren't close enough to the North Pole to have that phenomenon. The sun will set, it will go below the horizon, but it won't get completely dark. So looking into the north here, we're still on the 21st. We're going to go all the way through to night time. Oh, we might end up back on the 20th. Let's hop forward to the 21st. So we want to look at the sun just about 1 o'clock in the morning. So technically the 22nd. And we can see there's definitely a little bit of sunlight glow. We can make that a little bit more obvious. There we go. So the sun is close enough to our horizon that there's a little bit of light leaking over the sky. This is because if you were just a few degrees higher on the planet, if you were at the top of Finland or the top of Greenland, the sun would actually still be visible in the sky. If we push our way all the way through to the winter solstice again, we'll see the height of the sun in the sky getting lower. You won't see the sun getting lower, but there will be less light creeping over the horizon. So we can see here close to the 21st, the northern part of the sky is much, much darker. And if we come all the way back to the 21st of this month, we'll see that extra little bit of light in the sky. Now you can see the sky appearing to brighten and darken as we move through the weeks and months, but that's actually due to the position of the moon. So there we go on the 21st, definitely a little bit of light, even more obvious if we take a look from a little further away, seeing that light stretching up into the sky. So the light of the sun will have an effect all through the night on the nights of the summer solstice, but the sun will have practically no effect at all the rest of the time of the year. Even a couple of months either side of the summer solstice, the nights are shorter, but the sun goes far enough below the horizon that it won't interfere with our view of the night sky. And once we come up to the 21st, well, here we are at just 11:30. Jupiter and Saturn are already starting to come into the sky, and it's reasonably bright. There's also a good chance it will be reasonably warm so close to the middle of summer. So if you would like to go out and see Saturn and Jupiter, you may need to wait until a little after midnight, but luckily we're so close to the middle of summer, it should at least be warm enough to be comfortable looking at Saturn and Jupiter without being weighed down by a giant jacket. So, as we move around the sun, the height that we see the sun in the sky changes, how long we see it changes, even where it sets and rises will change. But really, the sun isn't moving at all. It's the Earth. As we orbit around the sun, our tilt appears to change. The north is always tilted the same direction, but for some of the year that means it's tilted towards the sun, and for some of the year it means we're tilted away. This is what causes our seasonal variation, and if we ever do visit other planets that don't have the same tilt as us, they just won't have that extreme variety between our warm summers and our cool winters. So even though short nights can make astronomy difficult and long nights can make things pretty cold, at least we get the change, we get that variation here on Earth. So I hope you get to enjoy the longest day of the year coming up on Sunday.